So one of the things that I've tried to do, this is not on your handout, but I tried to just print out these identities, and because we'll try to use some of these things as we go. And let's kind of get the idea. We end up doing some proofs of identities. So what we're going to do with this is we're going to multiply this stuff out. So you want to write this down first. Go ahead and write down the expression sine theta over 1 minus cosine theta like that. Okay, and we're going to work with some identities. What we're going to multiply it by is 1 plus cosine theta over 1 plus cosine theta like that. Okay, now part of this exercise is preparing you to do proofs of identities. Okay, so what we're going to do is we're going to do this. We're going to put it in one fraction. Now what I'm going to do is I'm going to leave that alone. I'm not going to distribute. You could. I'm not going to do that. But I'm going to go to the bottom. And if you look at the bottom, doesn't that look like FOIL? That's what it is, right? You got something times something. You got two terms. So what you're going to do is you're going to go ahead and you're going to FOIL. So that first term, 1 times 1, is going to give 1. The outside term is going to be 1 times positive cosine. So that's positive cosine theta. The inside term, you have a negative times positive. So that's negative cosine theta. And then the last term, what's the last term? Cosine times cosine is what? Cosine squared theta, right? And it's a negative times a positive. So that would be minus cosine squared theta like that. So you're going to do a lot of factoring and FOIL and multiply in this section, working with trigonometric expressions. Okay, one thing that you want to notice is that cancels. So let's write what we're left with. I'm going to leave this in a factored form like this. And then that's going to leave me with 1 minus cosine squared theta like that. Okay? Now, what I can do with this now is I'm going to use an identity with this because I've multiplied it out. Now I need to use an identity. So I'll try to zoom on this so you can see this okay. So the identity that comes in real handy on this problem is this one. Okay? The reason I know that is if I have a cosine squared, that makes me think immediately about this identity right here. So what I'm going to do is I'm going to do this, and you don't have to write this down, just pay attention to this, is you want to learn how to take an identity that you know and rearrange it in a way that's needed in your problem. So if I just moved that cosine to the other side, that identity would now read sine squared alpha equals 1 minus cosine squared alpha, correct? Okay, just move stuff. You're subtracting that from both sides. So what I'm going to do is I'm going to replace that with what it's equal to. It's equal to sine squared alpha theta, right? Okay, so I'm going to substitute equals for equals. So my next step, again, I'm going to leave the numerator as it is. Okay, like that. And then I'm going to replace that with sine squared theta like that. Okay, everybody with me on that? Okay, now, mathematically, what do you see happening in this expression right here? Something real simple that happens. What do you see? Got a cancellation, right? One of them cancels. Now, you can do that in your head, but what's really going on this problem is you have sine theta times 1 plus cosine theta over sine squared theta, which is just sine times sine. So that would cross out, and then you would be left basically with that solution. So when we multiply that out, you end up getting 1 plus cosine theta over sine theta like that. Okay, that's the idea. So this is an exercise that's preparing you for how to prove identities. That's the point behind that. Okay, if you do go on to take calculus in the future, I know like in my Calc 1 and Calc 2 classes this semester, we use identities. We do this kind of stuff a lot. We just kind of rearrange things with identities so we can do certain things. Okay, you guys follow what I did okay? Okay, now when you're doing problems in this section, you want to make sure that you look at your identities. You need to get these things memorized as fast as you can, but look at them as you're doing these problems because you'll need to do those. Use those quite a bit. Okay, so the next thing I want to look at then would be, let's work with this expression. We're just going to multiply this out. So if you look at this right there, that looks like FOIL, doesn't it? So just start FOILing it. Okay, you can do it in your head. So we got first term is going to be tangent squared theta. Outside term is going to be plus 1 tangent theta. Inside term is the same thing. 1 times tangent is tangent theta. Okay, then the last term you have 1 times 1 is plus 1 like that. Okay, then I'm going to bring down the secant squared theta. And then I'm going to bring down the tangent like that. So we're going to simplify that. And then we're going to look at our identities and see if there's anything we can do to kind of clean it up and simplify it a little bit. Okay, so notice what you have. In this expression right here, you have some like terms. You have tangent squared theta, and then these things go together. That's 1 plus 1 or 2 tangent theta. So that's going to give you 2 tangent theta plus 1, and then you're going to bring that down, then bring down the tangent like that. So what I've done is all I've done and accomplished so far is the FOIL. That's it. Okay, everybody follow that okay? Okay, now we got to think about identities now. Okay, all this stuff is all about identities. So I want you to look at this identity. Don't you think that identity would be useful? Yeah, because I've got tangent squareds and secant squares in here, and there's more than one way to handle this, by the way. What I'm going to do, and this is just my decision, you don't have to do it this way necessarily, but when I see this secant squared right here, I know that secant squared is equal to 1 plus tangent squared. So I'm going to plug in. I'm going to choose to do it that way. But again, that's my call. You could do this in another way. So I'm going to write this down as it is, leave all that stuff alone like that, plus 1. And then what I'm going to do is I'm going to replace that. That secant right there is going to get replaced with what it's equal to. And what's it equal to? 1 plus tangent squared. So I'm going to plug that in. Like that, and then again that whole mess is over tangent theta. So what I've done so far is just a couple of basic things. I FOILed that out, collected like terms, now I replace secant squared with what it's equal to in that identity. Everybody follow me on that okay? All right, now you're probably going to have a bunch of things cancel out. That's typically what happens, so let's kind of see what we have here to finish this up now. So it looks like I've got tangent to the secant theta plus 2 tangent theta plus 1. And be careful, that minus is going to distribute the signs. So you're going to have minus 1 minus tangent squared theta. Now you're going to start seeing that you're going to have several things that are going to cross out. Okay? All right, let's see. What cancels out? It looks like the tangent squareds cancel, and it looks like the 1's cancel. So it looks like what we have is we have 2 tangent theta over tangent theta. So what's the answer? 2, because the tangents cross out now. Who would have thought? All that mess is the same thing as 2. So this original expression right here, that thing right there is really equal to 2. Okay? So what you're again doing with this exercise is learning how to apply algebra and apply identities to simplify expressions. And it's very important to learn how to do that when you're working with identities. Okay, you guys follow that okay? Everybody with me on that? Okay. All right. Let's do a little bit more at that. One more problem, then we're going to start the rest of the section is verifying identities. Okay. Okay, so let me write this down. I'll just go ahead and write the expression down, and then we're going to look at our identities and think kind of what we can do here. Okay. So I'm going to slide down these identities and let's see if we find anything that comes in handy. All right. So let's look at the tangent. What's an identity we learned for the tangent? What's it equal to? Sine over cosine. Okay, that's 1. Let's go with it. Okay. And you just got to trust your instincts on this problem. You just find an identity and you go with it and you see where it leads you. Okay. So we're going to write this like this. I'm going to keep the cosine alone, and I'm going to keep the sine alone, but I'm going to change that to sine theta over cosine theta like that. Okay? So one thing that's very helpful when you're working with identities is to get everything written in sines and cosines. And then what we're going to do is we're going to add these two fractions together. So from algebra, if you're going to add two fractions, what do you have to accomplish? You've got to get a common denominator, right? The common denominator is just both of those things put together. So what you have to do is you have to do this particular fraction right here. You want it to have a cosine in the denominator, so you got to multiply it by cosine theta over cosine theta. And you have to do the same to the top and bottom, because if you don't, you're changing the problem, right? And then what does this one over here need? It needs 1 plus sine theta. So you're just matching them so they look exactly the same. All right, you guys okay with that? Now I have a common denominator. So what I need to do is I need to do these things. Multiply that numerator out. Cosine times cosine. That's cosine to the second theta. I'm just going to leave the denominator as is. Do not multiply out the denominator. Leave it factored, because often at the end of the problem something will cancel. And you want that in factored form for that reason. Okay, then I'm going to multiply this out. So that's sine times 1 is sine theta. And then I'm doing a distributive property. So sine theta times sine theta is sine squared theta, like that. And then that's all over that expression like that. Okay, and I don't know where this is going to lead me. I always have no idea when I do these problems. But I just trust my instincts and start going with it. Okay? All right, everybody with me so far? Okay, now what are we ready to do? We're ready to put this together in a fraction, right? So whenever we add fractions, when we have the common denominator, we keep that. So we're just ready now to put it in one fraction, and we'll see what we have going on here. Now, all of these things are like terms, so what I'm going to do is I'm just going to write it down as it is, cosine squared theta plus sine theta plus sine squared theta, like that. So I've got it all in one fraction, right? Everything's all together. Now it's time to start looking at our identities. So does anything jump out at you in that numerator? What jumps out at you? What's this? What's the cosine squared plus the sine squared? That's 1, exactly. So those things can be put together. So you have an identity right here. Okay, and the more you have these things memorized, the faster you see this stuff. Okay, so what I'm going to do is that goes together, and that just makes a 1. So now what I have is 1 plus sine theta over cosine theta times 1 plus sine theta, right? Now what happens? Something cancels, doesn't it? Good. Okay, these are the same. That whole thing is the same. Okay, whole thing's the same. So that cancels. That's really just 1. So that is going to give you 1 over cosine theta. Is there anything else you can do with that? Yeah, what is that? Secant. Okay, that's secant theta. We know that 1 over cosine is secant theta. That's another identity. So who would have thought? That mess right there is really just a secant theta. Okay, that's the purpose behind that, is to learn how to simplify expressions using identities. All right, you guys following along okay? Okay. Now, what I'm going to do on the next page here is the rest of what we're going to do is verify identities. The purpose of that gives you a little bit of experience with writing a proof of a certain type. And then for higher level math, if you're going to move into calculus and stuff, you got to know how to do the kind of thing I'm doing right now. You got to rearrange things. You do that all the time. Do it in physics. It's just kind of a common skill you have to have. So what I'm going to take you through is how to, our textbook calls it establishing identities. Some textbooks call it proving identities. Some say verifying. It doesn't matter. Okay? You're just showing that one side of this equation is equal to the other. So one of the things that I want to make sure that you get real solid on is how to write your steps. And I'm picky about how students write steps because you need to kind of do this in a neat framework. So I always want you to do this way. So write down the word proof. That's step 1. I always want that. Okay? Then what I want you to do is I want you to pick a side of this identity and write it down. But typically what you do is you write down the side that's the most complicated. So on this one, what do you think? I vote for the left side being more complicated. Do you agree with me? It's not very complicated, but it has 2 trig functions, so it's got more stuff. So write it down. And do not start your proofs any other way. Proof, pick a side, equal sign. Do not do it any other way. Okay? Now, what you start doing is you start looking at your identities and you keep going equals for equals. Ultimately, our goal is that pops out. Okay? So you got to trust your instincts. Okay, what's an identity that might come in handy for cotangent? Cosine over sine. Okay, like I said, trust your instincts. Okay, there's a good one right there. Cotangent is cosine over sine. So let's go ahead and write that. Okay, cosine theta over sine theta like that. Okay, what's an identity that might come in handy for a secant? 1 over cosine, all right? Trust your instincts. Try something. Okay, don't just sit there and do nothing. Try something. So that's 1 over cosine theta. Okay, so we got that. All right, what do you see happening? This one's not bad. Cosines cross out, so you're left with 1 over sine theta. So what is 1 over sine theta? Oh, we proved it. Look at that. That wasn't too bad. We're exactly where we needed to be. Okay, that's the logical thought process you're going through. So what you always want to do is write a side, write an equal sign, bring those equal signs down like that until you reach your goal. You see what I mean? Okay. All right. Isn't that cool? Yeah, it is cool. Yeah, I love it. This is my favorite stuff. And all of Trig proving identities is the best. Okay, it doesn't get any better than this. Okay, let's move this next one here. Okay, and let's see what we got going on. They're going to get a little bit more complicated as we go. Okay, we're going to write the word proof, and then we're going to pick a side. Obviously, to me, that left side is more complicated than that right side, so let's go ahead and write that down. And then we're going to trust our instincts and see what happens on this thing. Okay, what do you suggest? What kind of problem, algebra, what does that look like you could do? It looks like a distributive property, right? Just do a distributive property and see what happens. So we're going to do tangent theta, or tangent u, times cosecant u, minus tangent u times sine u like that. Okay? You do algebra in these problems, so if it looks like you need to multiply out, then go for it. Okay? Now, what we're going to do is we're going to see, well, let's think about identities. Okay? What do you want me to do for tangent and cosecant? What's your instinct, your thought? Tangent, what? Sine over cosine. Okay, that's one identity. Okay, look at them if you need to. So this one is going to be sine u over cosine u. Okay, that's an identity. You're going to use it all the time. I'll put my identities over here so you can see them a little bit better. Okay, how about cosecant? What do you want me to do? 1 over sine is a great idea. Okay, now let's move to the next one. How about tangent? Why don't we just do sine over cosine again? So that's sine over cosine there. And then this time I'm going to leave the sine alone. Okay? I could change it to 1 over cosecant, but that wouldn't accomplish anything. Okay? So let's see what happens in this step. Well, clearly that cancels out. That leaves us with 1 over cosine u. And then over here you would just multiply straight across, so you would have sine squared u over cosine u like that. Okay? Now, when you get to this point in the proof, sometimes it's not a bad idea to see what you're trying to prove. What we're hoping is this thing right here is going to turn into be a cosine, right? Well, I already have a common denominator, so I think it would make sense to go ahead and put everything together now, right? So let's do that, okay? So if we do that, we're going to have 1 minus sine squared u over cosine u like that. Okay? What do you suggest? We got to use an identity. What's the magic identity that we're going to use? Yeah, the one right here, that one right there. And you got to use it the right way. Now see, this you're going to do in your head. This is not a part of your proof, and you don't even have to have this on your paper, because for the most part, you're going to learn to do stuff like this in your head. So if I moved that sine to the other side, I would get cosine squared alpha equals 1 minus sine squared alpha. The reason I did that is because that is the same as that, right? So that means that what I'm going to have in my next step is I'm going to replace 1 minus sine with what it's equal to. It's equal to cosine squared u. Now I have that. Okay, now what happens? Something cancels, right? And then you're done, okay? So from here, you could bypass this step. You don't actually have to write the step I'm doing right now. because that's easy enough that you can do in your head. So we're left with cosine of u, problem done, okay? And by the way, the answer is not cosine u, the answer is the whole proof, okay? That's the whole thing I'm looking at, and I'm looking at steps like that. So again, you want to make sure that you have a side, keep your equal signs, keep going with that until you end up and reach your goal. Okay, did you guys follow what I did on that? Okay, and by the way, there's more than one way to do this. If you start working proofs out and comparing your proof to somebody sitting next to you, they may be totally different, but they both may be right. Okay, so you can be creative on this. Okay, let's continue on. Let's see what we got on the next one. Sometimes they're very easy, sometimes they're complicated. Sometimes you go in circles on these problems. Okay, so let's do this. Write down the word proof. Write down the the most complicated side. I have a feeling this one's going to be real easy. Okay, so I'm going to start that way. All right, what should I do? FOIL. Okay, do it. Okay, go ahead and multiply it out. And you can do that all in your head if you want to. You even don't have to write all 4 steps of FOIL because you're going to have a cancellation anyway. If you know that, just do it in your head. So 1 times 1 is 1. Outside term, 1 times cosine is cosine x. Inside term is negative cosine x. And then the last term is minus cosine squared x. Make sure you get all the signs and all the details right, and then that'll cancel. See, as a student, I wouldn't care if you just went immediately to 1 minus cosine squared x, because you can do that in your head. Okay? So now, well, what are you going to do now? We're really done if you think about it. We got one more step and we're done, because here's the identity we're going to apply. And again, this is not a part of your proof. This is just, you want to know that 1 minus cosine squared x is equal to the sine squared of x, right? So now you replace that with sine squared of x, and you're done. Look at that, 3 steps and we're done. Sometimes they work that way, all right? Okay, what do you think? Isn't this fun? Oh, I got one person that's kind of got a smile and think it's fun. It is fun. It's like a puzzle. Every problem is its own unique puzzle. Okay, now we're going to get to the better ones now. Some of them are going to be a little bit more complicated. Some of them are very straightforward. Some of them you will go in circles and you'll think, how in the world am I going to do this? You keep trying. I always tell students, if you're going in circles, you're not getting anywhere, wad your paper up and start with a new idea, because that will happen. Now this one right here would be one that might be like that. It's not a hard proof, but you might not see immediately what I see. But if you do, it's a super easy proof. So let's write down the most complicated side, which is going to obviously be the left side like that. So we're going to write that down. Now, it's always a good idea to think, at least think a little bit about what might come in handy on this problem. So a lot of times students might immediately think, let's FOIL. You might think that, you might FOIL it out. Or you might go ahead and start looking at these identities. Okay? This thing right here, what is 1 minus sine? Based on that identity, what is 1 minus sine? It's a cosine squared, right? Tangent squared plus 1. Ah, look at that, it's right there. What is 1 plus tangent squared? It's secant squared. So instead of foiling, I'm going to observe this thing. You want to observe that 1 plus tangent is really just the secant. So go ahead and replace that with secant squared of u, like that, okay? Now you go to this one, and again, you rearrange that in your head. So basically what that's going to be is that's going to be cosine squared u like that. Okay, you guys with me on that? That's the way to do the proof, and we're almost done. Do you guys know what a secant times a cosine is? They're reciprocals. What happens if you multiply a number by its reciprocal? What's 3/4 times 4/3? 1. You could just write 1 now if you wanted to, okay? Or you could do it this way. Some of you may be thinking, well, let's change the secant to 1 over cosine. You can do that if you want to, okay? But anyway, that's going to cross out, and then that leaves you 1. That's a pretty simple proof. If you FOILed it, you would get complicated and you would just get stuck. So you got to look for stuff like that. Sometimes you start that way instead of multiplying out. Okay? Does that look okay? Okay. All right. Now this one looks like a pretty complicated one here. So let's see what we got going on here. All right. So let's see. Let's write this down with our proof. And then let's write down the left side because it's obviously more complicated. If you really want to challenge yourself, start with the right side on this one. Okay, so I'm going to go like this, and then we'll kind of think about different things. A lot of times, like this one, I haven't worked these out. I haven't worked these out yet, so I just sometimes when I'm in class and I'm teaching this, occasionally I'll get stuck and start going in circles. So here's kind of my thoughts on this problem. I have two thoughts. One thought is I could get a common denominator and put it all together. Another thought I have, and a lot of times this is the best approach to go with, is to just work with the basic identities. So when I see a tangent, for instance, I might want to just go there. Okay, so I'm going to probably go there, sine over cosine. Even though it's going to make it more complicated, my thought process is I'm trying to prove that it's a cosecant. And a cosecant's related to a sine. So a lot of times it's beneficial to write everything in terms of cosines and sines. And then this thing, I'm going to use the identity 1 over cosine. Now it's going to start complicated, but I have a sneaking suspicion it's all going to work out. Okay, so what I'm going to do now is I'm going to write this, my equal sign, go ahead and write it there. So let's change the secant to 1 over cosine theta. Let's change the tangent to sine theta over cosine theta. And then over here, let's change the tangent to sine theta over cosine theta. And then the secant to 1 over cosine theta like that. Now that looks like we're making it too complicated. Well, sometimes on these problems they get complicated first, but then they start resolving themselves down. Okay, so here's what the next thing is. This is a complex fraction, right? Wouldn't it be nice if none of those cosines were there? Okay, we have the ability to get rid of them. If you want to make a cosine go away, just multiply by cosine so it cancels. So the way you have to approach this is like this. So we're actually just going to take this fraction right here, and we're going to multiply the top by the cosine, and but that forces us, of course, to multiply the bottom by the cosine. So I'm going to do that. And I'm going to do exactly the same thing over here. You would want to write this in as a part of your proof too. So I'm going to multiply that by cosine over cosine like that. Okay, now watch carefully how I do this. I do find a lot of times when I teach trig, students have very, very little experience with complex fractions. And you can do this all in your head. So it's easier for me to just point at stuff. So what I'm going to do is I'm going to distribute. Cosine times 1 is cosine, right? So you write that down. Then when you distribute this, what do you have? That cancels. So in your head, you would have cosine minus 1. Everybody see that? Just do that in your head so you don't have to write a lot of stuff on your paper. So I'm going to go ahead and write that thing down after the distributive property as cosine theta minus 1. Okay? Now if you look at the denominator, what are you left with? The cosines cancel, so what do you got? You got a sine. Okay? So let's see where that's going to take us now. Okay, so I have that. Now I'm going to move over to the next side here. And what's going to happen there is the cosines are going to cross out. That's going to leave a sine. Okay, and then I'm going to do the distributive property here. Cosine times 1 is cosine. And then I'm going to do that times that is going to give minus 1 like that. So what I've done is I've cleaned it up a little bit like that. Okay, you guys following that okay? Okay, doing distributive property and canceling. Now, remember, we're trying to make this just be negative 2 cosecant theta. My next thought is I have two fractions. It would be nice to just put them together, okay? Because the answer is just one has a cosecant in it. So let's get a common denominator and put this together like this. So the common denominator, I think we did something almost like this a little earlier. So we're going to kind of spread these out, get our common denominator, and see where it takes us. Okay, I have a sneaking suspicion it'll all work out. Okay, common denominator is those two things together. So I'm going to multiply this one by cosine theta minus 1 and cosine theta minus 1 like that. And then this one over here, I'm going to multiply that by sine theta times sine theta like that. All right? Now, it looks like you're making it complicated, but I bet once we get past this step, it's all going to start working its way out. What do you think? Okay, so what you want to do next is leave the denominator factor, because we're hoping that something will cancel at the end, and you want it to be in a factor form. You're going to FOIL that out. That will be sine squared. I get a sine squared, I start thinking of that identity, sine squared plus cosine squared equals 1. So let's do this. Let's FOIL this out. Okay, so if you do that, you're going to have cosine squared theta minus cosine theta minus cosine theta plus 1. Okay, and I'm going to leave that over the same denominator. Okay, like that. And then I go to the fraction on the right. You have a sine times a sine is a sine squared theta like that. Okay, I'll pause there for a minute and let's get that down and let's see what we have now, okay? Everybody okay with what I just did? I FOILed. Now what I'm going to do next here is I'm now ready to put it into one fraction. I've got a common denominator. It doesn't matter what order that denominator is in, so I'm just going to write sine theta, cosine theta minus 1. I keep the denominator. Now what I'm going to do is I'm going to go ahead and just put this all together like this. So what I have is I have a cosine squared theta. Those like terms go together to give minus 2 cosine theta plus 1 and plus sine squared theta. All right. Now remember what we were trying to prove had a 2 in it, right? The 2 has now shown up. So now it's starting to come together. What do you guys see in that numerator now? Do you see what I see? Should be popping right out at you. What's sine squared plus cosine squared? 1, right? This right here is going to be a 1. Okay, so you just write that down now. So your next step, you would just say, okay, that goes together to give 1. Then we have minus 2 cosine theta plus 1 all over sine theta, cosine theta like minus 1 like that. Okay, so I'm getting closer. I'm not there yet, but I'm getting closer. So I've got everything put together. So next thing I'm going to do, and I could have done this a minute ago, I could have done this step in my head, but 1 plus 1 is 2. So I have 2 minus 2 cosine theta over sine theta times cosine theta minus 1. We're almost there. Now I want to see if you guys see this or not. What do you notice in the numerator, if anything? It begins with F. What do you typically do in algebra all the time? You factor, exactly. That has a common factor of 2, doesn't it? Okay, so we're going to pull that out, okay, and see what happens. So this one's getting pretty complicated. I like this one. All right, so I'm going to just kind of move this over here, and I'm going to pull a 2 out. So that's going to be 1 minus cosine theta all over sine theta times cosine theta minus 1 like that. Okay? Take the 2 out. Now let me ask this question. I see students do this a lot. Do these things cancel? Are they exactly the same? They're not exactly the same, but they're close, right? So what you can do on this is you can do this. You can turn one of them around and see if this makes sense to you. I'm just going to take this thing and I'm going to turn it around. I can do that, but I have to do one thing to make it right. Okay, so I'm going to do that, but I'm going to put a negative there. Okay? Convince yourself of why that's right. It's not that big of a deal. Negative, you would have a negative cosine, right? And what's a negative negative? It's a positive. Anytime you turn something around, you have to put a negative in front. Here's a real simple example. If you had 3 minus 1, you know that's 2, right? Well, if you turned it around, that would be negative 2, right? But if you put a negative there, now it's right. Okay, so anytime you turn the order of something you subtract, you got to do that. Okay, now I'm going to leave the denominator alone. And now I'm getting super close to being done with the proof. So now what happens? That crosses out. That's negative 2 over sine theta. like that. Now, I think we were trying to prove negative 2 cosecant theta. Do you see it? You can now write the answer because it's there. Now, you can write this step if you want to, but I wouldn't care if you left this step off. I mean, that's just that. But then we know 1 over sine is cosecant. Man, that was an awesome proof. Okay, look at that. I got about 10 steps or so on that one. That's a good one. And you get into that some. Okay? The ones that have fractions in it, you'll kind of get that. You just keep going with it. But you got to be very solid with the algebra. I know a lot of students would not know how to do that thing, that backwards thing here. Does that make sense? That comes in handy, and you see that thing showing up quite a bit. Okay? All right, any questions? Okay, wasn't that fun? It was fun for me. I don't know about you. Okay, let's go to this next one. This one is one that I could tell, if I didn't have a lot of experience, I probably could easily get stuck on this one. This one turns out to be a super easy proof, if I'm thinking right. But there's a couple of approaches you could do on this. So let's start this one off like this. Pick a side. To me, both sides are equally complicated. Okay, so let's just pick the left side and write down tangent u minus 1 over tangent u plus 1, and then write the equal sign. You always start your proofs that way. Okay, what are some thoughts that we have? Well, probably the first thought that's going to come to most people is change the tangent to sine over cosine. Okay, you could run with that. If you did, I think you would go in circles. I'm not going to do that because I can tell in my mind I'm going to go in circles. So I'm going to think of something else. Another approach sometimes that you can do, and don't write this down, I'm going to erase this in a minute anyway. Sometimes another good thought is to multiply by the conjugate of the denominator. Okay, just change the signs. If you did that, I have a sneaking suspicion you also would run into circles and your proof might not get anywhere. So I'm going to show you what I see. Okay? Now this is kind of tricky, and you get better skill with this as you go on. So I'm going to kind of look at it like this. I'm seeing this. If I was to do this, and I just happened to see this when I was thinking about this, go ahead and write down your step like this. Leave a little gap underneath, because I'm going to do a little division step on this, and I'll show you what I see. Okay? Now this is a hard one to see too, but once you see it, the proof is 2 steps and you're done. What would happen if I divided that by a tangent? What's tangent divided by tangent? 1. Okay? What if I divided that also by a tangent? What's 1 over tangent? Cotangent. My God, it's there. Okay? I just saw that. Now, I'm sure there's other ways to prove this, but this is the easiest way. So what we're going to do, and we can do this, we can divide every piece of the numerator and every piece of the denominator by tangent. You have to do the same thing like that. The reason you're allowed to do that is because you're really just multiplying the numerator by 1 over tangent. And then it's there. So sometimes these problems, you can overcomplicate them. So sometimes it's a good idea to see what's happening. Well, that's 1. We know 1 over tangent's cotangent. Now you go to the bottom, that's 1. And we know that's cotangent. Isn't that cool? Okay, and most students would start by doing sine over cosine. And trust me, you just go in circles. But that's what would happen. So sometimes you have to look for things like that. You have to do something to that side to see if you can easily translate it into the other one. Now that was pretty slick, don't you think? Okay, yeah, okay. You gotta be alert and look for things like that. Okay, let's see this. We're gonna do a few more of these. I could just do this all day. I never get sick of it. I don't know about you. Okay, write the word proof, pick a side. Okay, so we have cosecant theta plus cotangent theta all over tangent theta plus sine theta with this one. I'm not seeing anything real quick and easy like on the last problem. I don't see anything anyway. So I'm just going to run with just some basic identities, okay? Problems like this, a lot of times, if you have cosecants and cotangents and tangents, you generally are just going to work with your fundamental identities, okay? Let's just roll this way. So cosecant, let's change that to 1 over sine theta, okay? Cotangent, what's that? Let's change that to cosine over sine. That's one of your fundamental, what we call the ratio identities. So let's do that. Okay, tangent, what's tangent? Sine over cosine. Okay, like that. Sine, you have two choices. Either leave it alone or change it to 1 over cosecant. Leave it alone, because it's good to have nothing but sines and cosines in there. Okay? So what we've done, and we saw this in a previous example, is we have what we call a complex fraction. Our answer doesn't have any fractions. So what you want to do is you want to get rid of a sign. How do you get rid of a sign in the denominator? You multiply by a sign. How do you get rid of a cosine? You multiply by a cosine. But you can't just do the top by the sine and the bottom by the cosine. The only way to do this correct mathematically is to multiply the numerator by sine theta and cosine theta at the same time. You can do that. And then you're forced to do the same thing to the bottom, and if you don't do that, you're changing the problem. And I'm putting the over 1 just to emphasize how that goes through there. Okay, so now what we have is a complex fraction, and seriously, when you see this, process this in your head. I'm going to stand up and kind of show you the way I do this, is like this. Just block that off. You're doing a distributive property. Okay, so if you multiplied that by that, what would happen? Sine would cross out, right? And what would you be left with? A cosine, right? Everybody see that? Now if you go here, that times that, what would happen? The sines would cross out, and you'd have cosine times cosine is cosine squared. You guys with me on that? Okay, do it in your head. The bottom the same way. Block that off. Cosine crosses out, sine times sine is sine squared. When you go here, sine squared cosine theta. You're doing a distributive property, but manage that in your head so you don't have to write a bunch of stuff out. Okay, so I'm doing distributive property. That's going to cross the sine out. That's going to leave cosine theta. Okay, go to the next one. Sines go away right there. Cosine times cosine is cosine squared theta, like that. All right, okay, go to the bottom. You're going to do a distributive property. So when you multiply that times that, the cosines go away. Sine times sine is sine squared theta. Okay. And then the last term, you're going to do sine cosine times sine, so that's sine squared theta times cosine theta. Okay, when I get up there and stand up and block stuff off, it's really easy for a student to see that. So when you're doing that, just kind of block off what you need to, and you'll process it okay. Okay, what could you do to the numerator? There's actually several things, but what do you see? Factoring's a big deal. Whenever you have fractions, factoring is the key. How do you factor that numerator? You take a cosine out. It has a common factor, right? What do you take out of the bottom? What's the common factor in the bottom? Sine squared. Take it out. Okay, do that. So you're going to go backwards on these problems. You might be thinking, oh, cosine, I changed that to 1 minus sine squared. You can try it, and it might work. But factoring is really helpful on this. So I'm going to take a cosine out. So cosine times 1 is cosine. Cosine times cosine is cosine, what? Not cosine squared theta, just cosine theta. Okay, like that. Okay, and then the bottom now I can take a sine squared out. So if I take a sine squared theta out, well, what are you left with? Sine squared times 1 would give you sine squared. And then sine squared times cosine is going to give that. You guys okay with the factoring? Okay, if you're not, man, you better get there because it's super important. You won't be able to do these well. Now, what happens? That crosses out, and it looks like what we're left with is a cosine theta over a sine squared theta. Now, let's look at what we're trying to prove. Sometimes you get in these problems and you forget what you're trying to prove. You're trying to prove that that's a cosecant cotangent. Let me ask you a question. Do you see a cotangent in that expression? Yeah, where is it? Cosine over sine, right? Okay, do you see a cosecant in there? Yeah, you got 1 over sine, right? So it's all there. Now you could go ahead and just write the next step like this. The best way to write this is just kind of split it up. You could say 1 over sine theta times cosine theta over sine theta. That's the best way to write that next step, because you know that you're trying to change it into a cosecant cotangent. Now you got it. So 1 over sine is cosecant, and then cosine over sine is going to be cotangent theta like that, and then you're done. Okay? All right, you guys following that okay? Okay? All right, so you're going to, when you get into these expressions with fractions, you're going to do that quite a bit. Okay, I'm going to do one more to finish this up, and then we're going to get into the next section. The next section turns out to be pretty easy, I think, for students. This one's got some challenges in it. Okay, so let's see what we're going to do with this one. Okay, so let's see. I'm going to work with the right side on this one. So I've got sine x, cosine squared x minus cosine fourth x like that. Now, I'm going to have to look at this and think about this a little bit and kind of think what's happening. This is another one that I could see how you could run in circles in this one. I think most students' original thought on this might be to just multiply it out, just do a distributive property, and that might work okay. I kind of am thinking something, and I'm not sure if my thought's the right one, but look at that parenthesis. Is there anything you can do in that parenthesis? There's several things you could do, actually. But factoring is so big, how do you factor that piece right there? You could take a cosine squared out, right? Okay, you have a common factor. Take it out and run with it, and let's see what happens. Now, I may be wrong, but that's what my instinct is let's go with that route, okay? I'm going to put a bracket, and I'm going to factor a cosine out of that. So if I do that, I'm going to have, our cosine squared is going to get factored out of that. So I have that. That's going to leave me with 1 minus cosine squared x like that, okay? Now, what's the next thing? What do you think? What is this? What is that? That's sine squared, right? Okay. So now you would have sine x cosine squared sine squared x. What are we trying to prove? Sine to the third x cosine squared. So we've already got a cosine squared, so it makes a lot of sense to leave that alone. Okay? And see, when I saw that, I was saying, well, I could get a cosine squared by doing that. So we're almost done. This would be a proof that you could do in 2 or 3 steps, or you could do probably in 20 steps. I like this way better. So this is sine x. That's now going to stay cosine squared x. But this thing right here changes to a sine squared x. So I'm going to write that as sine squared x like that. Okay, now we're pretty much done. Sine times sine squared is sine to the third x. Cosine squared x like that. That's it. Okay, that's how it goes, right? Now, since I've done these things for years, probably about 30 years, I can see these things a lot easier than somebody can that's studying this, but there are times when I don't see it, okay? So a lot of times I get with these problems and I have to play with them a little bit before I get them. Okay, you guys follow the logic on that okay? All right, okay. So that would be the idea.